Okay, so on your paper, you go past the first two things. Then it says what? Reciprocal identities, then quotient identities, then Pythagorean identities. Those are going to be the three main ones you use. The only time you're going to use the next two. Yes and no. You'll be able to use it on the test, so if you put stuff on there that you can't, then I'll just give you a new copy for your test. But if you want to write stuff now, that's fine. Okay. So the first three, then you have cofunction and then even odd. Cofunction, even odd, only use those if the problems have the parentheses that have what's in there. So like cofunction has to have either like 90 degrees or pi over 2 minus the angle. And then even odd has to have the parentheses with the negative angle. So the first three are really the only ones you're going to be using. Okay, and our goal is to simplify these down as far as they'll go. Mr. Zukowski was in here in second period, so he's already seen these problems.
Is he as confused as the second period was?
He told him exactly what to do on the first step.
Factor.
All right, now I know a lot of you have been leaving off the theta or the x part. You have to have that on these. Okay, because you're going to start doing ones that have like x and y together or alpha and beta in the same problem. So you need to get in the habit of putting whatever they use. So I think your paper, does that have u? Yeah. So u and theta are the same thing, just how you express the angle. Okay? Alright, so always look at factoring. So what do these two parts have in common?
That little circle.
A secant. The circle thing always happens. That's the angle. You can't factor out angles. They're attached to the trig function. Okay? Alright, so if I factor out a secant, I'm left with tangent squared plus 1. Everybody with me on that? If you're ever not with me, don't just be like, uh-huh. Like, tell me, okay? Because if you don't get this now, it's going to be really hard, like, as we go through chapter 5. Okay?
Okay, explain the plus one.
Okay, so like, if you're going to take a secant out, you can't be left with 0. You still have to have one left. Okay? You'll never have a zeros. Okay, anytime you see squares, especially if you see squareds plus 1 or 1 plus a squared or a minus, you're always going to look at, when you see something like this, always look at your Pythagorean identities. Okay, so do you see, if you go down to your Pythagorean identities, do you see something that has either 1 plus tangent squared or tangent squared plus 1?
Yes.
Okay, what is it equal to?
Secant squared u.
Secant squared, right? So we're going to replace this with secant squared because that's what it was equal to. So I replaced this and I left the secant that was on the outside.
What does the u mean?
It's just it's like how they express the angle. So u and theta and x and alpha, beta, they're going to use different terms. All it means is angle. Okay? So what's secant times secant squared?
Secant cubed.
Alright, so we're done.
That seems
That's-
really easy.
Yeah.
Now where's the twist?
That's the twist right there.
See,
It's definitely gonna be hard.
So why do you have to
Definitely.
secant, why did you change from the tangent squared to secant squared?
Because if you look at your Pythagorean identities, you see where it says, does it say 1 plus tangent squared or tangent squared plus 1?
1 plus 2.
Okay, so it's equal to secant squared, so I just replaced it.
Alright.
So it's like you're substituting in things that you find
To simplify it.
to simplify it. The goal would be to take it down to one term, but some parts you have to have two, and there's no way of knowing. But you're trying to go as small as you can go. Okay? Alright, we're going to try one similar, but a little bit harder.
similar but harder. No.
Okay, very first thing you always check is factoring. Is there anything that both of these parts have in common? Okay, so we're gonna factor out a cosine. So if I factor out a cosine, what am I left with? One minus sine squared. This doesn't disappear. If you divide, you're still left with one. Like 4 divided by 4 is not 0. 4 divided by 4 is 1. So cosine divided by cosine is 1. Okay, so I have a squared, adding something to it, okay? So I'm gonna go look at my Pythagorean identities. Do you see anything that says 1 minus sine squared?
No.
Do you see anything that has sine squared and a 1 in it?
Squared plus cosine squared.
Okay. So, is it sine squared first?
Yeah.
Okay. Is there a way I can make this look like this?
Yeah.
Okay, so how would I get 1 minus sine squared?
I don't know.
Okay. So cosine squared is 1 minus sine squared. Okay, you can manipulate equations however you want, as long as it's algebraically true. Like, I can't just make this a plus sign because I want to make it a plus sign. Okay, to move it over, we had to subtract it. Hey, that looks the same as this, right? So what could I replace 1 minus sine squared with?
Cosine squared.
Cosine squared, because that's what it's equal to. So this now becomes cosine squared. So like similar to this one, but we had to do more work because it wasn't right there where you could see it. So then this is cosine cubed, because cosine times cosine squared is cosine cubed. Okay, and you're gonna have to show your work on these. You can't just tell me what the answer is. Because there are, when we get to more of them, there's different ways of doing them. And so I'll follow your work to make sure you're doing it mathematically correct way. Alright, how do you feel about that one?
Good.
Who says awful?
Wait for it to-
Oh, good.
Everybody feels okay about the first two? Okay. Okay, if you see parentheses for the angle part and you have something going on, it's either going to be co-function or even odd. So instead of using theta, this one's we're using x as our angle. Okay, but it says pi over 2 minus x. If you see pi over 2 minus or 90 degrees minus something, or you see just negative x or negative theta, it's either co-function or even odd. So do you see this down there underneath the co-function identities?
Yeah.
Okay, what does it say this is equal to?
Sine.
Sine, it says sine u, right?
Yeah.
So this would become sine x. Okay, you only use co-function and even odd if it looks exactly like what it is on the paper. Okay, can I factor anything?
No.
No. Okay, so if I can't factor, I'm still not done because this will go further. So then I look to see, can I use my reciprocal identities or could I use my quotient identities to try to get something to cancel? Using either one of those, it's going to make fractions. And when you multiply fractions, remember diagonals will cancel. So you're trying to think like, can I make something look like I don't want to change this to be 1 over tangent. Because sine and tangent don't match up. So I want to find, is there something I can change that maybe can get a sine to cancel or a cotangent to cancel?
Yes.
Okay, what do you see?
Under quotient identities,
Okay,
the cotangent equals cosine over sine.
okay, does everybody see that?
Yeah.
Under cotangent, that's cosine over sine. Okay, well, why would we do that? Well, if this is over 1, what now happens to your signs?
They cancel.
They cancel. So then I have cosine over 1, which is just cosine. Okay, so if we go from here to here, look at your quotient identities.
So are you saying the cotangent, the one under quotient is the cotangent equals cosine over sine?
Yes, that's what I used, yep. So quotient only works for tangent and cotangent, there's only 2 of them under there. Because if I use reciprocal, nothing's gonna cancel. Because reciprocal of sine is cosecant, so I'd have 1 over cosecant times cotangent, that doesn't help me.
So, do you just take, so it tells you to do cosine over sine,
'Cause
and
those
then
are-
whatever's on the bottom, you just multiply that by itself over 1?
Well, these 2 are multiplied together, so this was a separate thing. So since nothing was on the bottom of this, we automatically put a 1. Just like if I had a 4 outside there, that would be over 1.
But like, since the equation doesn't tell you to do that, you only put that on the top because the other one has it on the bottom to cancel.
It's like the quotient is
No,
just cosine.
this right here, I didn't do anything with, it just came down. This part was what I used the quotient identity on. See how it says cotangent equals cosine over sine? That had, this part right here was not a part of that,
Oh.
okay? I only changed cotangent.
How did we know to use the quotient and variance?
How, you're looking for things to cancel. So, my 2 rules of thumb, factor first, and then if you can change everything to sines and cosines, something's gonna cancel. Okay? So, I already had a sign here, so I looked to see, can I change this to have sines and cosines to get it to cancel? The more you practice, the better you'll get at knowing what to do, but you want to try to break this down. In order to break it down, you have to get something to cancel. So when you're looking at both of those, or you're not, why would I not use Pythagorean on this one? There's nothing squared. So my only options were reciprocal and quotient. So when you're looking, try to see like, is there something I can substitute to get these to cancel? There's no, the bad thing about these is there's no like, this is what you do every single time.
So did you only pick that one because there's cotangent at the end?
Correct.
Like as long as it's somewhere in the problem?
And it was multiplied, so that way, like, I could substitute this, and these were multiplied together, so that's why they could cancel. If they were added together, they wouldn't cancel. Like, if you had sine plus cotangent, you could still change cotangent to be cosine over sine,
But you couldn't.
but those aren't gonna cancel because there's an adding sign. You can't cancel on fractions on adding.
So then how would you do that?
Well, you get common denominator.
So you want to do by sine.
Yeah. We'll do ones with fractions, but I don't think we're right there yet. You're confused on what?
I'm just not understanding why it's sine times cosine over sine.
Okay, do you see how we changed this into sine?
Yeah.
Okay, then I just brought out my cotangent. Okay, then I need to somehow figure out how to simplify this further. So somebody said that they looked on quotient and they saw cotangent was cosine over sine. So I replaced this with that. But I didn't do anything with this, so this stayed the same. Okay, but I know when I'm multiplying fractions, you can multiply across and bottom, but you can cancel diagonally. So then I could cancel these because that was multiplied together. What I do is multiply together because at the very beginning they were multiplied together. That help at all?
Yeah.
A little bit? You're lying to me, I can tell.
It does help a little.
I really think the more you practice, the better you'll get. Do you want to do 4, 5, or 6?
None of the above.
We did them all.
Let's do. Should we do that here?
That one is.
Everybody's the
Nice.
smartest.
No, that's
Yeah, they're totally different.
Oh,
I just looked at whatever one's real hard.
Okay.
Do it now.
Hayden, just because your life is kind of rough right now.
I think this stuff is really fun. But it's like problem solving.
I like this better than graphics.
I'm talking to you too.
Now since it's squared, you look at the Pythagorean.
You can, yeah. There's different ways of doing it.
Wait, are we trying this by ourselves?
Do you want to?
No.
There you go. Okay.
Let's do the
Yes.
one that makes like, that would be most obvious.
Okay.
Want to try?
I only think Pythagorean identities are most obvious when you have 1 plus or minus something or 2 that are squared added together. I wouldn't look at this and say those are both Pythagorean identities. Okay? Pythagoreans have to look exactly like they are there. Reciprocal and quotient, you can put squareds, cubes, fours, fifths, etc. on there. Okay? So I would not do Pythagorean. You could do it as a little bit more work, more steps. I would say, okay, I can't factor anything, so can I change these all to be sines and cosines? Those are the 2 things I always look at. Now, if there's like pluses and minuses going on, then I always look at Pythagorean. But since there's no pluses or minuses here, I wouldn't, because usually it's going to make your life harder. Okay? So, let's see, can we change these to have sines and cosines? Okay, what about tangent squared? Now on your paper, you don't have a tangent squared for reciprocal or quotient, but we can add the squares on there.
Tangent equals sine over cosine.
Okay, it does equal 1 over cotangent, but does that give us sines and cosines?
Tangent equals sine over cosine.
Okay, but on the quotient, tangent equals sine over cosine. Now, since it's tangent squared, this will become then sine squared over cosine squared. So if you want to write yourself a note and say Pythagoreans can't change, but reciprocals and quotients, you can put powers on them, that's fine. Is everybody with me on that part? Pythagoreans can't change. So cosine squared plus sine squared equals 1. You can't make those different powers. But reciprocal and quotients, you can make them squareds, cubes, fours, fifths. No. But like, since I'm changing tangent squared, those both had to be changed into squareds. But if I had a tangent cube over secant squared, it would be fine. Okay?
Okay.
Alright. Now, then I have my fraction bar. Then I have secant squared. Can I change secant squared in anything that has sine or cosine?
1 over cosine.
1 over cosine. Another reciprocal? So what would this become since it's squared? 1 over cosine squared. Okay, somebody said flip it. Who said it? Okay, why are you flipping?
Because you divide by a fraction.
Okay, fraction divided by fraction says you're going to multiply by the
Reciprocal.
reciprocal. Okay. And then what happens? Okay, if you're doing stuff and nothing cancels, something's wrong. Like I'm not saying start over, but by steps 2 or 3, things should start canceling.
Every single time.
Yeah. Okay. I mean, if you're doing like 5 or 6 steps and nothing's canceling, we should probably like, is there a different way of doing this?
Restart.
Okay, and a lot of times, this is what's gonna happen. You guys are gonna erase everything. Don't erase everything. Like, if you get stuck, come to me, and I'll be like, okay, here's where you we can keep going, or here's where you screwed up, because a lot of times you can do the first couple, and then you're like, you just go off on tangents, okay, so. I didn't even do that on purpose, okay, but try to get the first parts, okay. Alright. I think you can do this one on your own, let's see. Okay, if you can do this on your own, don't just say the answer out loud, just try to do it on your own.
We're supposed to try to do this on our own.
Sure, just see if you can.
Allison.
What? Just wait.
Just try.
Corey's never heard of that going off on a tangent. He's never heard anyone say that.
Really?
I've never either. I literally asked him. I was like, what are they talking about?
God, we have that on video. You're so close. That's that. That has to be that. Yep, good. Done? Done? Yeah. That's what you can do?
Yeah.
Okay, how many got sine squared? Okay,
Is it good?
that's good, that's
Oh,
answered.
okay.
She goes
This
to
is kind of fun.
Huh?
This is kind of fun.
I know, isn't this fun?
honestly
This is the most fun thing I
chemistry,
drink, I
and
think.
I hate chemistry.
Okay. I have a squared and I have something plus or minus added to it, so then I'm like, okay, Pythagorean identity. So what's cotangent squared plus 1?
1 over 2.
Hey. Did any of you stop here? No, you guys all went further? Awesome. You didn't make it there? Do you see where we see it on the Pythagorean?
This actually isn't as bad as that.
Are we gonna get to use this on like the quiz and stuff?
As long as you don't write anything on it that I don't tell you you can. If you do, I'll give you a new one.
Will you like check them the day before the quiz so that
I
if
can.
you do have something wrong, we can like make sure we have the like correct stuff for
Did
him?
you find it? Okay. Then what does 1 over cosecant squared turn into?
1 over sine squared.
Just sine squared. Okay, because 1 over secant.
Hey, just about that time, but before we dismiss, a couple announcements. Softball and baseball signups are Sunday, February 18th.